In this video, we're going to cover logarithm laws. So the first law of logarithms that is really useful is the product addition law, which simply states that log b of xy is equal to log b of x plus log b of y. So an example of this would be if you have log 25 of 30 plus log 25 of 5 over 6, then you can combine that into being log of 25 times 30 times 5 over 6, which can then just be reduced into log of 25, and then this reduces and you just get 5 times 5, so log 25, which is then just 1. And we know it's 1 because if we use the logarithm to exponent conversion rule or equation, we can get 25 raised to the first is equal to 25, which shows us that this is the right answer. So another useful logarithm law is the change of base formula, where we have log b of x is equal to log a of x divided by log a of b. This is really helpful when you have to convert or calculate logs and you don't have a calculator that can handle log bases that are different than like 10, which is the most common and called common log for a reason. And then another log rule that's really useful is the quotient rule, which is the opposite of the addition product rule. And that's just log b of x over y is equal to log b of x minus log b of y. And then another two that go hand in hand with the exponent rules, which once again are just the inverse of logarithms, are the log b of 1 is equal to 0, which is the 0 rule, and the log b of b is equal to 1, which is what we applied up here to get our answer when we had that. So another example using these rules is this. So since we don't have common bases, different bases, we know we can't use the addition rule, and so we're going to have to make some simplifications. So if we rewrite this, we know that 3 is not necessarily a multiple, but one of the roots of 27. And so we can rewrite that as log base 27 of cube root of 27, since 3 is equivalent to the cube root of 27, plus log base 9 of the square root of 9, since 3 is the square root of 9. And once we have this, we can convert them to exponential form using the exponential rules. So we end up with log of 27 raised to the 1 over 3, which is equivalent to the 3 cubed root of 27, plus log base 9 of 9 raised to the 1/2, which is equivalent to the square root of 9. And once we have this, we can use this rule, log of a times, it looks like a 9, log of a times x to the b is equal to b times log of a times x, or log of a of x. And this is called the log power rule. And so we can use this to convert our two parts here into 1/3 log of 27 plus 1/2 log of 9 by moving these out to the front, since we can according to this law. And then once we have that, we know from the identity rule up here that this just ends up being equal to 1 and this just ends up being equal to 1. So we can rewrite as 1/3 times 1 plus 1/2 times 1. And if we find common denominators, we end up with 2/6 plus 3/6, which is equal to 5/6, which is our answer for this problem. And so then the last example we'll do is going to be one that'll touch on having to use the change of base formula, which I mentioned above. And it is this guy right here. So the first thing we can do is use the quotient rule. Which allows us to split this guy up. So we'll end up with log base 2 of 17 minus log base 2 of 3 plus log base 2 of 10. And since the bases are the same in this problem, we can then just ignore them and use addition as we would just with normal numbers. And so we can reduce this down to being log base 2 of 24, since 17 minus 3 gives us 14 plus 10 gives us 24. And so then using the exponent to log and log to exponent conversion formula, we can convert this into being 24 is equal to 2 raised to the x. And with these ones, it's always good to start by trying to factor. So if we take 24 and we break it down, we're going to end up with 2 and 12, which breaks down to 2 and 6, which breaks down to 2 and 3. So since this doesn't factor out cleanly into just 2's, we know that we're going to have to find out what amount of a base 2 system 3 is. And so there's two ways to do this. One way is to do trial and error, which is kind of long and an involved process. And the other way is to use that change of base formula and a calculator. So that's the way we're going to go with this. So first we can expand this out into these. So we have our log base 2 of our first 2 plus log base 2 of our second 2 plus log base 2 of our third 2. And then we have plus log base 2 of that 3 that we have left over. And so these, once again, can just be dealt with using the identity rule up above, they just drop off and end up being equal to 1. So we end up with 1 plus 1 plus 1 plus log of 2 to the 3. And this just simplifies, obviously, into 3 plus log 2 of 3. And then this is where the change of base formula comes in. So I'll rewrite that quickly, which is change of base. We have log b of x is equal to log a of x divided by log a of b. And so now that we have this guy here, we can use it to figure out what our log 2 of 3 is going to be using a calculator. So with a being base 10, which is the base that the log function on your calculator is in, we can rewrite this to being equal to this. Log 2 of 3 is equal to log 10 of 3 divided by log 10 of 2, which, if you calculate it out, ends up being 0.477121 roughly, divided by 0.3010299 roughly, which then comes out to be 1.58496. And so that ends up being our answer for the component that is the log 2 of 3. So then if we're going to take that and run with it, we can convert and pull our 3 from above here. So we'll end up with 3 plus 1.58496. And then that just equals out to 4.58496. And if we want to check this, we just plug it in and use it as 2's exponent. And that ends up being equal to 23.9958, which is equal to 24, which is our answer. So it checks. So hopefully that was helpful. And enjoy your mathing.